Namaskar, Andariki Namaskaramulu, Subhodayam. Today, 2nd November 2022, and we are on 25th lecture on Sanatana Dharma during the course on certificate course on Sanatana Dharma. We have finished 1 month and now we are into 2nd month. We started with the topic Vedic mathematics by Dr. Goutham Mukherjee. And today is the 3rd day. So far we have learned vinculum and how to do addition with the vinculum and also multiplication. And today I think we will be going through the division part of it. So let us now start the session with Vande Mataram by Chala Chittibabu Garu and then do Pradhana by Ananthamji. Let us start.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayajasi Talam, Sasya Syamalam Mataram, Vande Mataram. Suprajyotna pulakitayaminim pullakusumita drumadala sobhinim suhasinim sumadhura bhashinim sukhadam varadam mataram vande mataram. Vande Mataram.
Vande Mataram. Thank you. Chala Chittibabu Garu, Dhanyavadaha. Ananthamji, namaste.
Namaskar.
Wish you to do Pradhana for all of us.
Yes, sir. Harihi Om, 1 minute meditation. Let us all relax. Close the eyes. Relax the body. Samam Kaya Shiro Grivam. Sit erect. Total concentration on breath without interfering. Pray, Lord, for another 2 hours. I will not entertain. I should not entertain any other thought other than the class. Om. 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 Ganana Antva Ganapati Gum Havamahe Kavin Kavinamupamashravastamam Jastarajam Brahmanam Brahmanaspata Anashranvannoti Visida Sadanam Mahaganapataye Namaha Prano Devi Saraswati Vajebirvajinivati Dhinamavityavatu Vagdevyai Namaha Gurureva Gatihi Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Shishurasmi Guroho मतिरस्ति गुरौ मम पाहि गुरो ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानामालयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करम् शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्तिः शान्तिः शान्तिः। हरिः ॐ श्रीगुरुभ्यो नमः। हरिः ॐ। नमस्कार।
धन्यवादः. धन्यवादः Anantanji. Now let us request our speaker Goutham Mukherjee ji to start his webinar.
Thank you, Karan sir.
Okay.
Namaskar to everybody. Sarvabha namaskar. Yesterday we just finished with this the comparison between the various Vedic methods and the Urdu Tijagabham and the conventional method, how the permutation are different actually in both the cases, otherwise it is the same thing. Now today we start with division. Let me do it. Wrong current slide. Wrong current slide. Yes. Yes. So division by Nikhilam method. Nikhilam means that Nikhilam Navata Charamang Dasta. Now what happens when suppose we start with a very small one, small division of two-digit dividend and one-digit divisor. Actually, here the purpose of the division is to find the quotient and remainder. We will not go to the fractional level. For that, there is a separate procedure altogether. And here we are interested in finding the remainder and the result. I mean the result and the remainder, quotient and remainder. So given a dividend and divisor, we find the quotient and the remainder, Q and R. So so start with say 34 divided by 9. 9 is actually now in 34 you see that nearest to 9 is power of 10 is 10 only. So if I divide by 34 by 10, what will happen? We'll know that 3 will be the quotient and 4 will be the remainder. But 9 is 1 short. So this 1 will get an advantage. How much? Every 10 there will be one that number of 1 into extra. That 3 into 1 is 3, and that will be extra, and that will contribute to the remainder. As soon as this is the minimum thing you can understand logically. Similarly, 61 by 9, So 6 is every 10 there is a 1 extra for this because of this 1. So in 60 there will be 6 extra. That 6 will be added to this already having the remainder. Had we divided by 10, so this will contribute. Then 1 plus 6 will be 7. That is the idea. Similarly, 123. So here also one get that in for 100. I mean, this will be 1 and could have been 2, but again there will be 3 and total 13 and 6 will be this thing. One, 2, and the next step it is 3, that becomes 6. So it is like this, 13 and 6. Say 253 divided by 9. So because of that 1 extra, now this will come to 2, and this adds, and this gets, there is, yeah, and yes, actually here we get only 1, so 1, and then 1 plus 2 actually is 3, because actually now this 1 number of tens has contributed, but there is already 2 tens. So 2 plus 1 is 3, and that 3 gets contributed to the remainder. So then final remainder becomes 6, and this quotient also becomes 13. Here also you have to understood. 253. So there is one. This 1 is extra. So had we divided 253 by 10, we would have gotten 25 as quotient and 3 as a remainder. Now, in case of 9, we get 1 extra in every 10, but every 100 also we get 20 extra. So that 20 contributed here, but already we had 5 in the 10th position. This with this 2 in the 10th position, total get 70. I mean, within 70 we get 7 extra. That 7 gets contributed to the remainder, and therefore this 5 plus 2 is 7, and then this total is 27 as remainder. 27 as quotient and 10 as remainder. Again, 10 is more than 9. So with 10, we again do that thing, and that we get 1 as quotient and 1 as remainder. That final remainder contributes to 1 with the 0, and the 1 quotient gets contributed with 27 to get total is 28 as quotient. This part is clear. Sometimes you have to do twice. If it is more than the dividend, I mean divisor, more than the divisor, then we again divide, and we finally, sometimes we just subtract 10, we subtract to it, 1 will be contributing to quotient and 1 will be remainder. This part is clear. Now we go to some higher these things. See, division by 9 for bigger numbers. Here, see, you have to understand, because actually this could have been done in a separate lines, but here because it is 9 and it is so short numbers are coming, we can put it in the same line. Otherwise, actually can come in different lines also. See, first step is that. So this is also the 1, 2, 3, 1, 2. This is 12,312 is the number. When we divide by 10, it gets 2 as a remainder and 1, 2, 3, 1 as quotient. First one, this one actually, actually this 10,000 group, it will be contributing to 1 to 100. Sorry, 1,000. This gets total 1,000 becomes 3,000 now. That 3 we multiply by 1, it gets 3, and now the 3 plus 3 total 100 becomes 6. That 6 gets contributed written here, and now earlier there was only 1 10. This is 6 is contributed as 10, so this becomes total 7, and 7 it goes to remainder part, and then
someone is asking a question, Dr. Chakrapani.
Pardon me.
Chakrapani is asking you a question. Yeah, Chakrapani, you can ask.
Yes. Please tell.
So I couldn't follow, please.
You have to say which one, which portion you could not follow, so that I can explain.
Previous step, sir.
Previous slide. Please tell.
Yes, sir. This one.
You followed this 34, 61, you followed, no? Every 10, there will be one extra. So this 6 is contributed towards remainder. Okay. Here also, here in 100, there is a 10 extra, because it's 100, there is a each one, so it is 10 extra. But this 10 contributes with the already having 10th digit, which is 2. 2 plus 1, 3. So that 3 gets contributed to remainder now. And total remainder becomes 6. And total quotient becomes 13. Is part is clear? Here also, in case of 253, it is the same thing, except here it was remainder was 6, but remainder is 10 here. Because it is remainder 10 is more than 9, more than the divisor. What we do? We again divide, and then we find that remainder and quotient for that one is 10, and then total quotient gets added, and total remainder gets added, and finally get this.
You're all unmuted, so you can unmute yourself and ask question.
Namaste, sir. Sorry, but I couldn't get this first step itself. You say for every 10 there is one extra. Like from the line 1 itself, I couldn't understand, and then after that, I tried to understand what you are saying. But then, sorry, I couldn't follow at all. If you could please explain.
See, I tell you, in the conventional division, what we do a trial, isn't it? We do a trial and we come nearest to the particular dividend. We multiply divisor with certain numbers, get a trial, and go to the nearest to the dividend, and we subtract and then find the remainder there in the particular step, first step, and then we again put another next digit down, and then again find the trial and do this thing. So in that process, we have to multiply. If the dividend is more, divisor is more. So here they have to do 9, 8, 7. You have to do all tables of those things, and we have to be big multiplication you have to do. But here there are particular cases are being taken where the this divisor is nearest to a power of 10. Like what we did earlier in case of multiplication is something nearest to power of 10. So here, if something is near to power of 10, then what the changes is happening? We don't have to do tables of 9, tables of 8, 7. There may be say 7, 8, 9. It could have been there for the divisor. So we don't have to do big multiplication. What we do? We find the deficiency. How much it is coming, the deficient from the nearest power of 10. Deficiency or extra. We will see the latter part. So here in 34, had we divided by 10, what will happen? We draw a line, very easy. When you divide something by 10's power, simply drawing a line by separating quotient and remainder will do. So in case, suppose we divide 34 by 10, so 3 becomes the quotient and 4 becomes the remainder. This part is clear to you?
Yes, sir. Yes, absolutely.
Now, 9 is, it is not 10. We are dividing by 9. So it is 1 less than 10. So because it is 1 less than 10, in every 10th digit, in 30, we get 7 extra. See, 9 into 3 is 27. We are getting 3 extra. That 3 extra gets contributed with the already existing remainder. Had we divided by 10. That is the idea. That 3 gets added to the remainder, and then remainder becomes 7. And of course, 3 becomes here. No other changes. 3 becomes the quotient. 3 remains as the quotient, but the remainder changes. These are simplest cases. So where you do not get much complication like this.
So shall I try to do the next one? Shall I try to think about the second one? So the second one is again is 61. So we divide it by 10. So the quotient will be 6. And then because 9 6 are 54, if I'm right, yes, 54. So the remaining is 6. So we write 6 below that.
Yeah.
And then because the first quotient was 6, so we write it there. Okay. Okay, fine.
So already existing remainder, had we divided by 10, that is there. And then because of this one, six more is contributed towards remainder. So it
Correct.
add the total of remainder and becomes 7. Here also, here actually it is 3 digits. Here, for every 100 there will be contribution because of this one. Every 10 there will be contribution of 1, and so on. We have to consider that. Therefore, it is another step is added here, namely another step actually, but we have written because it is 9 only, because very simple. So we wrote in the side, not below. Actually, could have been written in below. Later we higher numbers of digits will write below. So 123. So this is the 100 digits, and this contributes in the tens digit 1 in the 10 digits. That becomes total of 3 as 10 digits, and that gets contributed to the remainder. And this also gets contributed to quotient itself. So it becomes 13 becomes total quotient, and 6 becomes.
So, shall I repeat that again? Like this one is a bit again tricky. So because it's 123, we are again going to the closest hundreds, right? So hundreds will be 130.
Here there is a catch. I have seen there is some amount of overestimation or underestimation in that process, but this finally gets compensated. That I have seen in the process. It is actually coming from the remainder theorem, and there is in the equation there is finally it gets contributed, compensated, and you get 13 into 9, 117, and plus 6 is 123. Matching here, we can easily see that it is correct. But the procedure is like this. Here, this one, yes, I'll contribute. I'll change it to pointer. This will come down here. Okay. Now these two will be added, and this addition will come down here. It will come down. And actually put it down. And then finally we add the remainder, and we add the quotient also. Here also these two gets, because this 1 multiplied by 2 is there. The 1 is there everywhere actually. So 2 is this 2. And this 2 plus 5 is 7. This 7 goes there. The total of these things went there. And then total becomes 10, and this becomes 27. And this 10 again gets contributed to 1 and 0. And this every progress we will be seeing it. We will be accustomed to it. So let me progress, and if there is a problem, I will see. Similarly here.
Sir, sorry, but I mean, I think I lost you in the last two sums. Like I totally lost you.
Let me first explain the procedure. You just remember the procedure, and later on we will get an explanation. Okay? I'm trying to explain, but let us first learn the procedures, how it is happening. Then we can later on we can explain. Okay?
Okay. Yeah. Okay, sir.
But let us first see the procedure. We don't have to think much. Actually, when you learn a procedure, the algebra, corresponding algebra are in the background. But we do not always think in the algebra, because if we do that, it will be unnecessarily waste of time and waste of mental power, and your processing will be slow. So here, like from childhood, we have learned this division process somewhat mechanically. We didn't always do that. We don't always have to do trial, and you subtract, and you drop down the next one. Again, you do trial, and so on until unless all the digits are exhausted. Unless you want for a decimal point, you finish there and you do a quotient will be coming towards right, and below it will be remainder. We know that procedure. We never question that how it is coming, but it is coming in a particular way. Particular algebra is there behind. Similarly, here also the procedure is different. Let us learn the procedure, and you see that how it is coming. Now, later on, we'll see that what is the explanation. So here 1 2 3 1 2, and this again that thing remainder and quotient line we draw. Because it is one digit, so only one will be there. And then 1 is division, so we have to multiply by 1. Instead of dividing by 9, it is very interesting in case of this Nikilam method. Instead of multiplying by 9, dividing by 9, we are actually basically multiplying by 1. See, 1 into 1, this becomes 1. This 2 plus 1, 3, and this becomes 3. 3 plus 3 is 6. This becomes 6. And 1 plus 6 is 7, and they become 7. Finally, we add all of them. 2 plus 7 is 9. 6 plus 1 is 7. 3 plus 3 is 6. 2 plus 1 is 3, and 1 is 1. So this becomes 1, 3, 6, 7 as quotient, and 9 becomes remainder. Again, 9 is the same as this one, more than or less. So it becomes finally 0 as the remainder, and this 9, because of 9, 1 gets contributed towards quotient and becomes 1, 3, 6, 8. It adds.
Sir, excuse me, sir. Excuse me. Sir, the division, the first few minutes, I could not able to log in. So please explain from the beginning this sum 1, 2, 3, 1 divided by 2. And divided by 9, please explain, sir. From the beginning, not
From the beginning.
How to proceed further. First, from initial steps to the last.
Yeah. So 1, 2, 3, 1, 2. So we are dividing with 9. 9 is single digit. So put a put a separation line between the quotient and remainder part. Okay. This is the quotient as a remainder to start with, and then I play with the 1, not with 9. We are interested with calculating with 1. That is multiplication, not kind of division. So 1 gets multiplied with 1 and put it below the next digit. Now this 2 plus 1 is 3. Put in the next digit. 3 plus 3 is 6. Put in the next digit, below next digit. 6 plus 1 is 7. Put in the, it went up to remainder part. Here it is process finished. This kind of putting the digit is getting finished. Then we add finally. 7 plus 2 is 9. 1 plus 6 is 7. 3 plus 3 is 6. 2 plus 1 is 3. 1 is 1. So, but 9 is equal to 9. So this becomes again 1 more quotient will be contributed, and the remainder will be 0. Because 9, if we divided by 9, it will be quotient will be 0, and remainder is 1. So that 1 gets contributed here, and the final is 1367, it becomes 1368, and becomes remainder becomes 0. We take another example: 120021 divided by 2. Suppose we really divide by 9. How you see how much time it takes? You have to do trial with this 1, then again 9. Divide, subtract, it becomes 3, becomes 30. 9 into 3 becomes this thing, and so on. It takes very long time, unnecessarily to do the tables of 9 and so on. Here you don't have to do like that. The deficient is 1 only. The Nikilam by Nikilam Navatah Charamam Dasataha. So 9 is 1, and 10 minus 9 is 1. And here 1 we multiplied by 1 becomes 1, becomes down to the next digit. 2 plus 1 is 3, it comes to next digit. 3 plus 1 is 3, again 3 plus 1 is 3, 3 plus 0 is 3, 3 plus 0 is 3, 3 plus 2 is 5, 5 plus 1 is 6. And then finally we add all these things. 6 plus 2 is 8, 5, 1 plus, all this add, we add all these things, and we get, within a few seconds, we get the quotient and remainder. Imagine you just, later, not during like this, later on you divide this, try to divide this
Yes,
number with
sir.
9.
Now
How
I
much time
found
would
it.
you take?
Mm.
It can go on, see, there can be very big ones, but very easily can get that quotient and remainder by this procedure. But there is a particular, as I told, it should be near about that a power of 10, this one. Okay.
Yes. Got it, sir. Thank you very much.
And then again, shall we take another example? 101164 and 649. Okay, this big number. So again, the deficiency is 1. Nikilam, the 10 minus nearest power to 10, nearest power is 10, 10 minus 9 is 1. So that 1 gets multiplied always. So 1 into 1 is 1, 1 plus 0 again, 1 in, that into 1 is 1, 1 plus 1, 2, 2 into 1 is 2, 1 plus 2, 3, 3 plus 6, 9, 9 plus 14, 9 plus 4, 13. 13 becomes 22 as the remainder, and this becomes quotient, but 22 remainder in case of 9 is not possible. So again, we do 2 versus 2, and 2 gets again 2 into 9 is 2, and we get 2 quotient and 4 remainder. That earlier we got this one from this process. This 2 gets contributed, and then we get the final remainder quotient as 112405, and this 4 becomes remainder. Okay.
Sir,
Now,
1 second. You are giving with 9, no? Like that, if we do 8, 10 minus 8, 2
we are coming.
Okay, sir. Thank you.
8. Here, we are 8, we are dividing by 8. So 8 is 2 less than 10. So we write 2 here. We have to work with 2. Now we have to work with 2. Like in case of 9, we work with 1. We are working with 2. That 23 we divide by 8. So 2 into 2 multiplied by 2 is 4, and the 4 plus the existing remainder, 4 plus 3 is 7, and we get 2 as a quotient and 7 as a remainder. We get another one, 31. 2 multiplied by 3 is 6, and 6 plus 1 is 7. Similarly, we are, let me finish with 8. 234 divided by 8. So 2 is this 2 is a deficient Nikilam method, and 2 into 2 is 4. 4 plus 3 is 7. 7 into 2 is 14. That 14 plus 1, this gets 18, and it becomes 27. But 18 is more than 8. Again, we do. This becomes again it contributes 1 into 4. That way you can do, and then you finally get 2 as what is that? Yes.
Remainder.
14. Yes. 18 is there. This is 18. So it is again that 8 into 2 is 16. So that 2 gets added here, 29, and then 2 remains. This I could have done like this also. 18, 8. So 2, and then this becomes 18. This 22 is 2 here. How? 2. It becomes actually difficult. Another step. So again becomes 1 and 10, and this 1 and 10, it becomes again this 0 and 2. So this becomes finally 1 plus 1, 2 again. This gets contributed here. It becomes 29 and 2. We could have done, as I told, that nothing conventional method is also 1. As we get 18 here, immediately you see that it is remainder is 2, and quotient is contributing to 2, and therefore it is 29 and the remainder 2. Similarly, 345 divided by 2. 345 divided by 2. We get here 3 into 2 is 6. 6 plus 4 is 20, and that gets contributed to 6 10, and 10 into 2 is 20. It becomes 25 and 4, and 25 again is another 3 and 1. So it becomes 43 and continues to 1. 24 is 3 actually, and 20, this 1 is remainder. Now you come to division by 7. So here 3 is deficient, so to multiply by 3. So 1 into 3 is 3, and it becomes 1 and 5. 2 and 0, again the 3 into 6, it becomes 2 and 6. 4, in case of 6, it is 4. So 4 gets multiplied, 1 into 4 is 4, and 1 plus 4 is 5. Any question from this one?
Sir, please explain 234 by 8 and 345 by 8.
234 by 8. So here, in case of 8, in the Nikhilam, it goes to 10 minus 8 is 2. Okay. Nikhilam Navata Charamang Dasata. Okay. So 8 is this 2, it is coming. And this 2 into 2 is 4. Okay. 2 into 2 is 4. This 3 plus 4 is 7. That's 7, it is 7. 7 into 2 is 14. Is correct? Is understood?
Yes, sir, got it.
14 plus 4 is 18, and 23 plus 4 is 27. Again, 18 is more than 8. So again, we do it. It is 18 if we divide by 8. It contributes 2 more to this thing. This becomes 2 more for the quotient, and 2 is the remainder. 2 is the remainder. Similarly, here also 25, we got that process as a remainder. The 25 gets 3 contributed towards the quotient, and 1 is remainder. So 7, 6, all according to the deficiency from 4 or 10, we multiply and we get the answer. Now we come to 2 digits. 2 digit bar single processing. So to understand the process, the single processing, very easy one. So suppose you want to divide 111 by 89. So in Nikhilam method, if we do 89, it will be 1 and 1 vinculum, 1 vinculum. So that we are not interested in that. We are interested in only the accepting the leftmost 1. That means basically we are subtracting from the nearest power of 10. In case of this, power of 10 is 100, and 89 is 11 deficient for that, and we have to work with 11. Now, because it is a 2 digit, we put a drawing line in 111. We put in this place between these 2 digits from right we leave, and then we put a line, and that is the quotient and remainder line, division line. And 11 into 1 is 11, so it becomes 1 and 22. 87, so it is 13 less than 100. So again, it is 222. 2 into 13 is 26. So 26 plus 22 is 48, and this 2 is 2. 88, it is 12 deficient. So 3 into 12 is 36. 36 plus 33 is 69, and this is 3. 888, 112. So this 1 into 112 is 112. That gets added to the quotient, and then we get 1 as, added to the remainder, and 1 gets quotient. 789 is 211. So it is again 2 into, here it is 2, 3, 4, 5. 2 into 211 is 422. And the remainder is added, remainders are added, and quotient is added. Quotient is 2. Okay, this is clear? I think you just see the process, and later on we will explain that there is some from the remainder theorem or from the that consideration of the deficiency or more than that, it will be contributing actually. And finally, there is some in the intermediate step, there is some overestimation or underestimation in the but finally it gets adjusted. Sometimes you do multiple steps also. Division by 2 or more digits requiring multiple processing. Sorry, 89. We are dividing 1111, 1111 by 89. Here also 11 is the 100 minus nearest 10 minus 89 is 11. So 11 we will be working with. In the 11, when we multiply this, the first digit, we find that 11 there is no place. So 1 we do here and another we throw towards remainder side. But mind it is remainder side, but actually it is inherently, there is a 0 here. It gets contributed towards the first part of the remainder, the 10th digit of the remainder. This is very interesting. You have to see. And we do not write that 0, but it is there. Okay. Now 1 plus 1 is 2. 2 into 11 is 22. This gets we write 22 like this one. Finally, we get add 1 plus 2 is 3, and 1 plus 1 plus 2 is 4, and this 11 plus 1 is 12. Here.
Sorry, sir, I didn't get this one. So when you divide that 1111 by 11, first you take 100 minus 89, so it is 11. So 11 times 1, 11 into 1 time is like 11. Then the remainder, why we get 1 here, 1 by 1?
Because the 11 into 1 is 11. We have to write that 11, but there is no further position to write. It gets thrown towards remainder. There is a particular logic behind that. It gets actually slightly overestimated, underestimated, but that gets compensated later. But these are the background. We don't have to think that. Only we know that this gets contributed to the first digit because it is a higher digit. No, so inherently this is actually we are writing 110, but we are not writing the 0. You understand? So
how you got this? How you got this 1 stroke 1 0?
No, 0 you do not write 1 stroke 1. That 1 we add finally to that first digit of the remainder. First digit of the remainder is this one. We add there. That means this is a 0. Inherent 0 is there. Now 11 into this 11 into 1 is 11. So we write 11. We write 11, but 1 is on the quotient side, another is remainder side. And then this 1 plus 1 becomes 2, and 2 into 11 is 22. The 22 wholly we, because there is no place to write further. Further right, there is no further digit of the quotient. So we write in the remainder part, and this 22, and finally 22 gets added here. And 1
this,
and
this 1 quotient and 1 remainder comes from the 11 of
no, actually
quotient.
one quotient and 10 remainder, and that actually inherent is there because
okay, that's fine.
It is
1
the
quotient and 10
digit.
remainder.
It is the 100th digit, so there is a there actually it is 10th digit. We do not write that. While adding, we add it with that this digit. We could have written 0 also, but it is not done. Actually, this is the procedure. It looks very clear, clean. 1 plus 2 is 3, and 1 plus 1 plus 2 is 4, and 11 plus 1 is 12. 789 and 211. 21456.
No,
So,
no. Actually, if sir, just 1 second, sir. This 11 quotient with 11 short, that becomes 121. So in 121, you explained here 110.
no, that's what I was
Am I
saying.
getting? And
Actually,
this one again, one more of 11. One more of 11 here, and the 11 here, it becomes 22. Am I correct?
Yeah. Actually, it gets when I'm writing 110, but actually it is more. So
No,
that
why don't you split this into a little extra steps and just to get into the mind?
No. This becomes a procedure. This becomes a
This
procedure.
becomes-
You don't have to do much calculation in the background. It is very straight cut. It is you write it just 1 and 1 you are dividing, and 1 plus
This 1
is
and 1,
18.
where from I get it? I'm saying.
Huh?
This 1 and 1, where from I get it? And it is derived from the previous line 11
No.
of the
This
quotient.
1 into 11 is 11. That 11 you are
Oh,
writing
this
time.
11 into 1 is 11. Correct?
Yeah.
And
that's what.
Okay, that I understand this 1, 11. And how you got this 22, sir?
1 plus 1 is 2. This
1
2
plus
into
1
11
is
is
2.
2 into 11 is 22.
So the procedure is on the first digit of 1 into 11 is a 1 quotient, 1 remainder, or
Yes.
10 remainder rather. And 1 plus 1 becomes 2 into 11 is 22. Okay, sir.
We
Thank
do
you.
more examples, we will see it actually. So it is 789. The deficiency is 211 now. Nikhilam Lavata Charamagdasata. This becomes 9 minus 7 is 2. 9 minus 8 is 1, and 10 minus 9 is 1. So in Nikhilam we get this one. We do not write first one and this thing bar. We do not that. Here it is a slightly different form. There is a reason behind that also. So it is only you do Nikhilam Navatas, don't consider anything else, subtracting 1 or adding 1, something like that. Here 211. So now we have to work with 211 and not with 789. Imagine you are dividing this thing, you have to do so much of tables and calculation with this one, 789 multiplied by 4, 5, etc. It is not required. What you have to do? This 2 multiplied by 211 is 422. We write 4 here and 22 on the remainder side. Again, there is an invisible 0. Don't always think of that. Take the procedure and you will get it that it will be 4 and 22. That way dividing. Now, this 4 plus 1 is 5. 5 you multiplied by 211. So 1055. But mind it, last digit of this thing will match with this one, and this will match with this one. 10 will be remainder. 10 is totally with the contributing with the 4 and 2. So when we remember the quotient part we add, it becomes 21 plus 4 is 25, and then here it becomes 6 plus 5 is 11, and then we get 5 plus 2 plus that carry 1 is 3. Maybe that I can shift it slightly. It got shifted anyway. I can bring it. So 6 plus 5 is 1, 11, 1. Then 5 plus 5 plus 2 plus 1 is 13. This 3 is there. 4 plus 2 plus 0 and plus that 1 carry is 7. And this 1 is 1. Now we effectively got how much? 25 as quotient and 25 as quotient, and remainder is 1731. So 1731 is more than 789. Again we do. So actually when it is getting more and more away from 1000, it gets actually this kind of complication, multiple processing, as I told, multiple processing, single processing and multiple processing, multiple lines and multiple processing. 1731. So 201 again. So this 1 plus 201, it becomes not that difficult at times. So it becomes 942 and 1. But again, 942 is more than 789. You simply subtract. So
how we get 942?
942. 1 into 211 is 211 fully, because there is no further digits to write below. So everything gets contributed to our remainder side. 1 plus 1 is 2, 3 plus 1 is 4, and 7 plus 2 is 9. 940.
But in the previous one, how do you get 1055?
1055 is this 1 plus 4 is 5. 1 plus 4 is 5. 5 multiplied by this 5 multiplied by 211 is 1055. Okay.
Okay.
And this 942, then again 942 becomes 1 and 153. That this one and this one gets total becomes 2. So 2 plus this earlier we got this one. The earlier we got 25. This 25 plus this 2 gets 27, and this remainder gets remainder. Clear? Two steps. So now 789 is a divisor, and we divide 1 to 1, 4, 5, 6. So again, 1 into this 211 is the as previous 211 is the nihilum of that. 9 minus 7 is 2, 9 minus 2 is 9 minus 8 is 1, and 10 minus 9 is 1. So 211 or 1000 minus 789 is 211, the same thing. So 1 into 211 is 211. 21 comes here, 1 comes here. Actually, there is 2 zeros, but we are not writing that. It contributes to that hundreds digits of the remainder. And again, this it becomes 2 plus 2 is how much? 4. 4 into 211 is 844. 800 again, there is an inherent 0, but we do not write here. 44. And then finally, as I told, in the intermediate step, there is a lot of overestimation, underestimation, or actually underestimation, and then the writing style is different also. That actually gets compensated finally. That is the way of compensation. But we do not think always. Now 1 plus 1 plus 8 is 10, and the 10 into 211 is 2110. 2110 fully have to write towards the remainder side. That gets the compensation of all the other previous underestimations. 6 plus 0 is 6. 5 plus 4 plus 1 is 9, 10, and the 10 and the 4, the 1 plus 4, the 5 plus 6, 6 plus 4, 14 and 1, 15. No, no, not that. 6 plus 6 is 0. 5 plus 4 plus 1 is 0, 1. Then 4 plus 1 plus 2 plus 4, 1. Yes, this again is 11. That becomes 2 plus 1 is 3. Is clear? Basically, you are adding 456 plus 100 plus 440 plus 2110. So this becomes added to 3100 as remainder, but remainder again you have to do work with the remainder, and we get this multiplied by 211 is 633. This added to the remainder, the 739, and 3 becomes the quotient. That these 3 contributed to this 150 and becomes 153 and 739. You see that looks so complicated, but still, if you just in a conventional method, if you do divide 1, 2, 1, 4, 5, 6 divided by 789, you see how much time it takes, isn't it? Is it not easier than that? Anybody?
I didn't get the 150. That is, we are getting 153 by 739. Can you explain that last step, sir?
Oh, see, here we got by this process.
Sir, please explain. Sir, please from 2110 onwards, please, sir.
2110. Now, after we get this 2110, because this 1 totally is that 1000 digits. I mean, 100 digits, but 2, it becomes 1000 digits actually. Now, earlier we got 456, then this 100 basically, individual is 100. This is 440. And there is, how we are getting 210? This 1 plus 1 plus 8 is 10. This is 10, no? Addition of these 3, the addition of these 2 are 4. Okay? That 4 into 211, you got 844. Okay? You understand, no? So I start from the beginning. See, 1 into 211 is 211 like this. We write in this format. 21 here and 1 here in the 100 digit. And then 2 plus 2 is 4. This 4 into 211 is 844. 8 we write here and 44 we write in the remainder side. Now 1 plus 1 plus 8 is 10. The 10 multiplied by 211 becomes 2110. Is it clear how we are 2110 coming? Clear, no?
Yes, sir. Yes, sir.
Yeah. Now we are adding all these things, keeping the position of that, means there are zeros, individual zeros. And then a total of this gets contributed when a total becomes 3106. But 3106 much more than 789. Again, we do this process. So again, this 3 into 211 is 633. This gets the remainder now, and 3 becomes 3 more contribute. 3 more are we obtained by virtue of dividing 3106 divided by 79. We got 3 more as a quotient. That 3 quotient gets added to the 153 you already got and gets to 153, and this remainder we got to remainder, final remainder. Money, we cannot say that it is 150 as quotient and 3106 as remainder. No. So we have to see that how much of in the remainder, how much again quotient remainder comes from there. Final remainder becomes 739, and then 3 becomes quotient that gets added. 153 is the final quotient. Is clear? Now it's clear?
Yes, sir. Yeah. I forgot to see that whole thing from the top 789, like 3,000, because I'm seeing directly 150 by 3106 directly.
So in between there is process. So there are these two processors two processors required here. So here we'll find another case. Here we'll see another case where there will be 3 steps of processing will be required. So let me see. So I slightly changes these digits to 231456 divided by 789. Okay. So you tell me now. Someone please explain me now. How we are getting? Please, someone, anybody can volunteer, please.
Yes, sir, I can try. Shall I?
Please volunteer someone that how we are getting.
Okay,
What is the procedure? How to proceed?
Yeah. So just to start with 789. So using all by 9 and then last one by 10. So we subtract that and we get 211. And then that 211 is multiplied by 2, the first 2 of 231. And we get 422.
Right, exactly. Very good.
And the next is we add
347 211 into 7 is equal to 1477.
Exactly.
Right.
Very good. Very
Okay,
good.
right. Okay. So we add 3 and 4, so we get 14. 7, and then 7 we multiplied by 211, so we get 1477, which is perfectly fine.
Yeah.
And then we add all the ones that we have. Okay, no, not yet. We are not there yet. So we again multiply. We just add.
Yeah, there is a catch here. So actually, When you finally add, we consider it is 14 as carry here, but actually 14 is sitting below 1 and 2. And we could have sparsed it, we have to see. Now it is 14 gets contributed here. So in the next step, we have to write, add 14 plus 2 plus 1. We have met 17. 17 into this thing. So this we are multiplying by 17, not this 4, not this 4. So because we got that time this 1477, no, this 14 is sitting below 1 and 2. So 2 plus 1 plus 14 is 17. 17 into this 3587. This is very interesting. Yes.
So,
And
so
then,
this is where it gets a bit complicated because 17 to 1 will be a bit too bigger to calculate.
Too big to calculate, yes. 17 into this thing, bigger to calculate. Even
Okay,
then, if you see always multiplying by 789 by something, and get, we would have gotten 2, 9. So 9 into 789, one step will come, no? This is the final, quotient. So imagine how we are dividing this thing by conventional method. At one particular step, the 9 into 789 you have to. But it is also, you are telling the 17 into 211. I think it is better, no? So 7 into 211, and then we are getting 3587, and we are adding this thing, it becomes 5013. But 5013 again we have to do. So here you are getting 211 into 5 is 1055, you become 1068, and 5 remainder. But 106 is also more than this. So this becomes 211 added to that. This one again 211 was there. 279, and this 5 plus 1 is 6. 6 plus, see, this 289 and this 5 and this 1, these all are quotients. The final quotient is 287 plus 5
plus 1 plus 1.
So 293, and remainder is final remainder is this, which is until unless it is less than 789. So we
Sir, here small doubt, sir. Here we are, it has come 1477. Why we are placing 14 this side and 77, but and underneath that 3587 we are placing in quotient place, no? That is remainder place. Here.
3,587. This 3,000, it cannot contribute to the quotient because there is a barrier between quotient and remainder, because relation between quotient and remainder not are in terms of 1,000.
Here, sir, here both are 4 digits only, now 1477 as well as 3587.
No, see, you are telling 4 digits. That means inherently you are thinking that relation between those digits are connected with powers of 10, isn't it? 1477 is 1 is in 1,000, 4 is in 100, and 77 are. But actually, in case of 3,587 going towards remainder, should have gone to remainder. 3 is not in kind of 3 cannot contribute. 3 cannot contribute towards cannot contribute towards quotient, because relation between this part and this part is 789 and not 1,000. So 3 is not 113. Actually, 3 is here to be adjusted with 789 always. It has to be divided 789. Okay, that is the reason. That actually that is the thing that comes by logic. Initially by practice and then by logic, that this 14 actually contributes towards the last digit of that, and then multiply with that 17 by this one, and then wholly it gets towards, because there is no further digit in the on the quotient side. So everything gets thrown in the remainder side. Then finally it gets added, and then we get like this.
Sir, one doubt here.
Yes.
You are multiplying 2 with 211, and because you are taking 2 in the hundreds place, we started writing 42 from the tens place.
422.
422 in that 42 is we started writing from tens place of the quotient.
And 200 in the.
And when you come to the 4 plus 7, 4 plus 3, 7, we have to start from the units place, no? 1477.
No. Units place. Yeah, we have written everything in units place. That is 14 we have written actually in units place. But in the quotient side, there is no harm. If we add these things, in any case, 14 plus 2 plus 1 is 17, and this 1 is carry. So 3 plus 4 plus that 1 is 8. In any case, we write this way or that way. In case of quotient, it doesn't matter.
But actually, after 422, we have to just add, isn't it? 231 plus 42 and 456 plus 2, we have to add, isn't it? Where from this 1477 came, I didn't understand. Only 1477. First of all, okay.
1477 actually is, this is actually 14. Actually, you have to imagine while calculating the next step of the process, you have to imagine that 14 is sitting in the units place fully, not 4 only. So 14 plus 2 plus 1 is 17, and this gets multiplied by 17.
My doubt is, we have to write this 1477. We should start writing below 2, no?
Yeah, below 2 we are writing 14. Below, no, not that, because no. 14 actually is contributing towards quotient. We cannot throw this 4 towards remainder side, no. To understand the logic behind this, because see, had we got say a 9, we would be placing, had we got 9, we would have placed it below 4, no problem. Now, in case of, you tell me, in case of it becomes more than 9, so why it should be throwing towards remainder side, and 1 will be only contributing towards quotient? No, 14 will contribute fully towards quotient.
How to know that?
Because no, there is this process is a continuous one. Actually, we could have written in there. I'll tell you how to do that. 2, 3, 1, 4, 5, 6. Okay, I will write 2, 3, 1, 4, 5, 6. Okay.
Okay.
The dividing line, and we're dividing by 789, and it's 211. We write 4, 2, and 2.
Okay.
3 plus 4 is 7. So 7 into this 2 is 14. 14.
Yes.
77.
That's what I'm saying.
14.
Yes, sir.
Now, so this is 14, but dividing line is this one.
Yes.
1477. And 14 plus 2 plus is 17. We becomes, what is that? The 3506, no? What was that?
3587.
Like that. 17 into this, 3507, no? How much is that? 17.
Must be 3587.
Sorry, 3587. 3587. This is the idea. But when you are adding finally, whether you add 14 or write 1 here, doesn't matter. 14 plus 2 plus 1 is 17. 1 is carry. 3 plus 4 plus is 8 and 2. When even if you write whole 14 as here, it didn't matter here. Only adding to the quotient side. But here it mattered. Here it does matter, because 14 plus 2 plus 2, next step calculation, you have to do it 17. So that is the idea. Okay. Now it's clear slightly. So we wrote in the past condition and wrote the role of each digit is important here. We are actually doing digit by digit. So role of each digit is important, and therefore it is a thing. So here again, this clear now. Again, another example you are getting.
But how can that?
How? Any question? Let me do another example. Will be clearly. It will be. Now we come to a longer. We have written actually longer complication. It becomes more complicated as it is away from 1000, when nearest 10, it gets more further complicated. So 341,567 divided by 654. This here the Nikilam is 346 gets multiplied with 3 becomes 1038. 1038 as again I can write is 10 in this place, but you wrote like this, no problem here as far as this is concerned. But you have to write that it is actually 10 is contributing towards this digit. So 10 plus 4 is 14. The 14 multiplied by 14 actually is 14. Actually again you have to write, you can write in this past condition. So this 10 plus this 4. Actually, you are not supposed to write in the unit digit. Actually, 10 is written here in below, and 3 is written below 1. So 10 plus 4 is 14. 14 into 346 is 4844. Again, 48 is actually below. 48 is actually below this 3. 48 plus 3 plus 1 is 51. 51 multiplied by 346 is this much big amount. This becomes 19. You don't follow all the calculations. You know how it is complicated, becoming complicated. 317. Therefore, this particular method is not that applicable. What I want to say so is that this is not gets applicable. Either you do conventional or there is a thing called state division by which it comes very easily 520. It is not in the course right now. In the later, if the time remains, I will show how to do state division. So again, it gets 492 and 19,799 as remainder. Again, I have to do the process. This one and 346 into 300, this 46. This becomes 22 into this one is 4152, and then becomes 5,411 with 22 as a quotient. Again 5,411 we do 346, 1730 and 5 and 2146. Again we do 2146, this thing. 3 and this becomes 200. 8 and 33 we do minus of that. So 179 gets the final remainder, and these 3 is there. So finally we collect down, or those are scattered, and collect all the quotients. This 492, and start from the beginning. This 492 plus this 22 plus this 5 plus this 3. Enter 2 and then 1 from there. So total 3. The total contributed to us 522, and remainder is 179. So this gets complicated. So it shows that this particular method actually not that much applicable here. It becomes complicated. Either you do conventional because it has become smaller. So you can do conventional, no problem. You have to do multiplication with 6, 5, and 4. Doesn't matter. And then, but otherwise, Vedic mathematics, there is other method is there. State division is called, by which you can do it. Now, there is again, there are special cases are there in case of Nikilam. Division by sub-base technique. So consider 1011 divided by 23. So we see that if we multiply by 4, it gets near to a power of 10, 92. Now, 1011, we are dividing, forgetting about 23 now. Dividing 1011 by 92. 8 again is Nikhilum of that. Here is 0 and 8. Earlier we did it and becomes 10 and 91. 10 is the quotient. Had we divided by 92, we had gotten 10 as a quotient and 91 as a 91 as a remainder. But actually we are dividing by 23. So with this result, we cannot get satisfied by 92. What will happen? Had we divided by 23, in any case, this we had multiplied by 4 to get 92. So it is 4 times less, 1/4 of that. So in the quotient, we get 4 times of the quotient, becomes 40. But 91 also cannot remain as 92 when dividing by 23. So there are 3 more of 23 gets fitted in 91 and remainder becomes 22. So it is finally got these 3 is added to this 40. This 3 plus 40 is 43. 43 is the remainder and 22 is the, 43 is the quotient and 22 is the remainder. Clear? What is not clear here? You are doing by procedure as well as by logic.
Please explain it again.
Again. So if we 1011 by 23 if we do, so 23 into 4 is 92.
What is 4? How do we get this 4?
No, we have to fit that 23. How multiplying by what? It gets near to a power of 10.
Oh.
So power of 10 is 100, and when you multiply 23 into 4, it gets 92. It is near to power of 10, but slightly below.
Okay.
So 23 into 4 is 92, and 90 with do the process, do the same process with 92 as if 92 is the your divisor.
91.
We get 10 and 91, but 10 is we divided by 92, we got 10. So if we divide it by 23, we divide, then it becomes 4 times, obviously. Okay, it becomes 40. However, in 91 also, it cannot be a proper remainder in case of 23, because in the 91 we get 3 as a quotient, and it is actually 69.
69. So 22.
1 is equal to 69 plus 22. That means 3 more are coming as a quotient, and 22 is the remainder. So finally, you are getting adding. So this is another technique. But now I come so just because 15 minutes are there. Of course, question and answer is separately not required. Now we are doing it opposite. We are, if time requires, we can even come back to similar example of this. And now we come to another one. Can you see the top level of the top line of this? It is called Paravarta method. If something is something blocking on the top line, no?
No, Mahoday.
As a division by Paravarta method. Actually, it is the opposite of Nikhilam, you can say. It is, so far we have considered the divisor is below power of 10, but it is actually now we are considering above 10, above power of 10. So it is 112. How much it is deficient, it actually becomes opposite of that. So here it becomes
minus 12.
112 minus. Because I have to work with, earlier we worked with the positive thing. Here we have to work with negative thing, vinculum. Actually, in vinculum we are writing side, always not writing above. And we are sparsing the digits so that it becomes very clear. Here again, 1 into that minus 1 minus 2 is a minus 1 minus 12. That means actually. Here too there is actually opposite quotient and remainder. This is, or in our book it is not given. So also, yeah, I also not.
Then ఇది ఒక
It is like this. Again, had we divided
take the
by
printout and
100,
keep it.
100.
And if you go to the 100 meters, you will
Had we
understand.
divided by 100, we would have gotten 12 as quotient and 34 as remainder. Had we divided by 1000 here in the next one, we would have gotten 13 as quotient and 456 as remainder. So therefore, we are writing the dividing line here. So -1 and -2. And again, 2 into -1 is how much? 2 plus -1 is 1. 1 into -1 and -2 is again -1 and -2. This 4 minus 2 becomes 2. 3 minus 2 minus 1 becomes 0. And 12 minus 1 is 11. So 11 is quotient and 0 minus 2 is remainder. Clear? Very simple cases.
Sir, how we have taken this -2, -4, -6?
Oh yeah, here I am telling. Next one. Here, 1 into -1, -2, -3, -1, -2, -3.
Okay.
2 plus -1 is 2. Sorry, 3 plus -1 is 2 plus 2. So 2 into 1 plus -1, -2, -3 is -2, -4, -3.
Okay.
So again we add this one, 4 minus this thing, -2. And 4 minus 2 is 0 and 13 minus 1 is 12. But actually, this is, here you have to do some kind of, lot of in that. This remainder is -20. So 12 is quotient and remainder is -20. How it is possible? It is not possible. Remainder is -20 is not possible. So here it is.
Yes, sir.
What we do, we divide it by this, subtract this 20 from there. So we overestimated the quotient. Quotient is not that much because remainder is negative. So basically, 1 we should get from this one. This minus this is 1103. So basically, 1103 should be remainder and 1 will be less here. So 11 actually is quotient and 1103 is remainder. Okay.
How the quotient has come down from 12 to 11?
Because here the -20 was the remainder. But remainder cannot be negative. We always want positive remainder.
Oh,
so we borrow 1 from the quotient. We borrow 1 from the quotient. So quotient becomes less. And that borrowed 1, we borrowed 1 from the quotient. So remainder, that when that comes to remainder side, it contributes 1, 1, 2, 3 because 1, 1, 2, 3 is the divisor. So one quotient, each quotient has a value actually. Each quotient is value not 1000, but is 1123 is the value of each of the quotients. Okay. So in otherwise you can say that 12 into 1123 minus 20 is same as 11 into 1123 plus 1103, isn't it? This is, both of them are 1, 3, 4, 5, 6. Basically 1, 3, 4, 5, 6. When either I can say that 12 into 1, 1, 2, 3. Actually what? This dividend into dividend into quotient into divisor. Quotient into divisor plus remainder is the division, isn't it? Dividend is equal to what? divisor into quotient, or quotient into divisor plus remainder. So this is actually this one, but we got more quotient. So that quotient into divisor, that remainder was minus 20. So to do minus 20, it is the same thing as 1, 3, 4, 5, 6. So we do not write quotient as negative in the negative form. We always write quotient. Want to see always quotient. I'm sorry. Always want to see remainder as positive. So we again borrow 1 and we becomes 110. Clear? Okay. Next one. So this one actually the same kind of situations. 1, 2, 3 becomes minus 2, minus 3. 2, 3, 4, 5, 6. Again, there is a line here actually. Because it is 100. So it becomes minus 4, minus 6, and 3 minus 4 is positive. 3 minus 4 is minus 1 now, and minus 1 into minus 2 minus 3 becomes 2, 3. It becomes positive. And 4 plus 2 minus 6 is 0. Again, it contributes 0. Then last line becomes 0. It balances and becomes, when we add 6, 5 plus 2 is 8. And 2 minus 1, 0. This 2 minus 1 actually, as we know, vinculum format, 2 minus 1 is nothing but 19, 19, and the 86 is like that. You just understand this one?
Yes, sir. This is simple.
Now, there is another technique. Earlier we did in Nichilam method, but within Nichilam method, we didn't apply vinculum. So 880, because we had earlier 113, 114, this kind of thing. We had 118. We do it this way. We write is 1 plus 2 minus 2. Here is less than 1000. So therefore, this becomes 3 digits like this. It is not thus 18. No, it is 118. So 1 plus 2 minus 2. This 2 minus 2 is actually 18. Here we do 4 into this one. 4 plus 2 plus 8 minus 8. So it becomes 1. This becomes 8 and 4, 4. In one line, you got such a looking big calculation. Again, here actually it is 1000, near to 1000. So quotient and remainder line is 3 digits. So quotient is 4 and remainder is 481. See how much it is straightforward? You just get the logic, do the proper processing, and you get it.
Sir, how we get this 1 plus 2 minus 2?
It is 118.
Okay.
So 18 actually again 8 is more than 5. So we write it 2 and 2 vinculum. So earlier we did no. 18 can be expressed as 2 and 2 vinculum. Here we are writing vinculum in the side, means that it actually is in the minus form we are writing. That's sparsing that digits. So it becomes 118 becomes. We could have done 118, but unnecessarily you don't have to want to multiply by 8. We always saw it, no? So to avoid multiplying by 8, we converted it into vinculum. So here also we did convert it into vinculum 2 and minus 2. So 4, 8 and minus 8. See how it became easier. You try with 118, it can be done. 118 becomes 470, 472. Sorry. $472. In any case, you will getting 81. You'll get also possible. But here we to make it shorter. We did like that. So it is more actually. You always have to work with 8. I don't want to work with 8. I want to work with minus 2. That is the idea. So next one is this one, divided 2699 by 224. 224. This 112. I divide by 2. Now 224, it is not, cannot be handled properly by this one. we have to have something near about power of 10. This is 224 is not near about power of 10. So, but when you divide it by 2, it will get 112 becomes near about power of 10. So it becomes divided by, we are dividing basically by 112 minus 1 minus 2. So 2 into minus 1 minus 2 is minus 2 minus 4. 2 plus minus 1 is 4. So 4 into minus 1 minus 2 is minus 4 minus 8. 9 plus 8 is 1. 4 plus 9 minus 4 is 1. And this 26 minus 2 is 24. It becomes 24 and 11. But we divided it sort of that base and sub base kind of thing. So here we do, had we divided 2699, had we divided 2699 by 224, we would have gotten 24 as quotient and 11 as remainder. Now actually we didn't divide it by we divided by 112. So we got 24 and 11. But actually we should have divided by 224. So you would have gotten half of that quotient. So quotient becomes half. So it becomes 12. However, remainder is remainder. Remainder will not be divided because remainder some remainder we are getting by with the help of 112. We're getting the same remainder by 200, double of that also, triple by that also. Okay. Here it gets slightly complicated. I'll finish this one. By this one, I don't want to keep for the next class. 1699 by 223. So 223, when we half, we get 111 and a half. And this becomes minus 1 and a half. 6 minus 1 is 5. When you multiply it by minus 1 and a half, becomes minus 5 and minus 7 and a half. So this becomes 9 minus 7 and a half is 1 and a half. 9 minus 5 minus 1 and a half is 2 and a half. And this 6 minus 1 is 5. And 16 minus 1 is 15. Now again, we have to divide it by, started with lesser half of the original divisor. We have to again do the half in the remainder. So because actually it is double, so it is to be half. 7 and a half has the remainder, and 2 and a half and 2 and a half. But here there is a catch. 1 and a half in a unit digit is 1 and a half. But 2 and a half in tens digit, actually it will be 25. But 15 plus this 7 and a half is 22 and a half. Total is 22 as a half. Okay. Oh, I'm sorry. No, I'm totally. This 15 becomes 7 and a half. 7 and a half. 7 and a half actually is 7 quotient. But this half in the quotient side is actually half of that 223. So it becomes 111 and a half. This part we must consider. Huh? So 111 and a half, 25 and 1 and a half becomes 138 quotient. What? Any reaction?
Mahodaya, out of curiosity, how long did it take for you to master this? Because traditional way, we have been trained, we have trained our brains doing the traditional way. Now, it is good to have options, but to master it, it looks like it cannot be done in 3 or 4 days. Like we will get
if required, we will be doing the tutorial class or we give answers, question answers. Hey, what is that?
Personally, how long did it take for you, Mahodaya, to master all these techniques?
Actually, see, in the normal cases, there are no problem, no? When I got the special case, so in the normal case, you didn't have any difficulty, no? You understood up to this? Understood this one also?
Understanding wise, yes, Mahodaya, but to be able to reproduce it by will, I don't think it will come easily without practice. So I was just wondering.
You practice this, you take some state test, your own examples, and then you will be understanding. You try to do that, and what mistake it can get back to me. This one, which is not a special case. What is a simple case, you can understand this one, but this is actually a special case. When this is actually not coming near about a power of 10, rather it is a factor of that thing is coming near about power of 10. Okay, so a factor of that is coming, what is 112. In case of this one, there was no problem because it was a even number. So it gets to also a integer. But 222 also would have not been problem because 222 divided by 2 is 111. Would not have problem. But problem came when it is coming to 223 because it is a even number, a odd number. So odd number is because half will be produced. And similarly, it will be half will be remaining here, and these halves will be contributed somewhere and add all these halves. And but finally, it's more interesting. In a half in the tens place becomes contribute 5. So becomes this 2.5 becomes 25. 2.5 into 10 is 25. 1.5 is 1.5. And but in the quotient side, a half contributing towards quotient side will be actually, it is actually meaning to 23.5. 23 into half. So 112 into half, 112.5. So this contributed to a total becomes 123, 138, and it becomes that 7 as a quotient. Okay. So tomorrow we'll start with completely a new topic. So because the days are only 5, so days have to be divided that way. But this one, anybody can interact with me how this is coming further. How many people really understood? This first part is this one is understood or not?
Yes, Mahodaya.
Yes,
Understood, sir.
Yeah. Only you had problem with the half, isn't it? You had the problem with half. As I told, the half is actually coming out of this.
Yeah, I think we will have a little revision tomorrow.
Maybe that I can, a short revision I can make with this one.
Now the dose is overdose now. Not being able to digest. So in the beginning, things are very clear. As we keep going, it's getting saturated, mind getting saturated.
See, this is the most clever thing. We are not dividing something with large numbers.
Now
we are seeing that how much it is deficient or excess over a nearest power of 10. And power of 10, when you divide, we simply get a dividing line. There is no problem in that. Power of 10. But we have to see how much it is extra or deficient from the power of 10. And we are only working with that one. That is the main idea behind this. So this is, I also found it very interesting. We don't have to handle with big numbers. We handle with small numbers, and to look at that deficiency or excess over the otherwise quotient and remainder. Otherwise quotient and remainder means had we divided by nearest power of 10. we are playing with that one only. No, this is the idea about the both the Nikhilam and Paravarta method of division.
Definitely a brilliant way of divide and conquer with the small, take one aspect of it and keep doing the same thing again and again to get it.
Exactly.
But so much of practice needed on our end, Mahodaya. It's more like
these are practice.
Unlearn and relearn kind of thing.
You know, ordinarily when I studied this one, this half was, I also took almost 2 hours. I mean 1.5 hours to 2 hours, figuring out that how come it has become 111 and a half is contributing towards this remainder.
I think we are running out of time, so we'll close for today.
Yeah.
Thank you.
Thank you. We have already question and answers.
Right.
Okay.
I close the sharing now.
Thank you. Thank you, Goutham ji, for your, you have painstakingly prepared a PPT also and then explained. It is not very easy to teach mathematics online, but you made it as simple as possible. You have to catch the hand of the student, then only these things come. But the way you have explained, the most of the slides in the beginning are very well understood. Maybe at later part, the mind has got blocked for some people. So they will practice at home and come tomorrow. That will be clear for them. So now let us do Prarthana and Janaganamana.
One request. Swasti prajabhya paripalayantam nyayena margena mahim mahishaah go brahmanebhyah shubhamastu nityam lokah samastah sukhino bhavantu kale varshatu parjanyah prithvi sasyashalini deshoyam kshobarahitah brahmanas santu nirbhayah aputrah putrinas santu pautrinah adhanas sadanas santu jivantu sharadam shatam sarve bhavantu sukhinah sarve santu niramayah sarve bhadrani pashyantu ma kaschid dukkha bhag bhavet asato ma sadgamaya tamaso ma jyotirgamaya mrityorma amrutangamaya om shanti 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 Om Purnamadah Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnamevavasishyate Om Shanti 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 Harihi Om Shri Gurubhyo Namaha Harihi Om.
Dhanyavada. Dhanyavada Anantanji. Just to remind all of you that Friday at 8 a.m. there will be an exam on Panchangam. So now let us do Chandaganamana.
Sir, excuse me. What time is it? Morning
8 o'clock. 8 o'clock.
8 evening.
Morning 8 o'clock.
Okay, morning 8. Okay, sir. Fine. Thank you.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे Jaya He, Jaya He, Jaya 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 He, Jai Hind.
Jai Hind. Dhanyavadaha.
One request.
Today we have finished our session. All those people